Welcome to YQ Academy, SQL Interview Questions and Answers. 1. What is the difference between union and union all? 1. Union. The union operator combines the result sets of multiple select queries into a single result set while eliminating duplicate rows. It ensures that only distinct rows are included in the final result set. If there are any duplicate rows present in the individual result sets, only one instance of the duplicate row will be included in the final result set. 2. Union all. The union all operator also combines the result sets of multiple select queries into a single result set, but it does not remove duplicate rows. It simply concatenates all the rows from the individual result sets, including any duplicate rows. As a result, the final result set may contain duplicate rows if they are present in the individual result sets. 2. What is B-tree? B-tree, short for balanced tree, is a self-balancing data structure used in computer science and databases for efficient storage and retrieval of data. It is commonly used as an indexing structure in databases to provide fast access to data based on a key. Properties of B-tree. 1. Balanced. The B-tree is self-balancing, which means that the height of the tree is kept relatively small and consistent. This balancing property ensures that the performance of operations like searching, insertion, and deletion remains efficient even as the tree grows. 2. Sorted keys. The keys in a B-tree are stored in a sorted order. This allows for efficient searching and range queries as the keys are organized in a logical sequence. 3. Multiple child nodes. Each node in a B-tree can have multiple child nodes, unlike binary trees which have at most 2 child nodes. This property allows a B-tree to hold a large number of keys and provides a high degree of branching, reducing the height of the tree. 4. Multiple keys in a node. Each node in a B-tree can hold multiple keys and corresponding pointers to child nodes or data. This property allows for efficient utilization of memory and reduces the number of disk accesses required for data retrieval. 3. What does it mean when we say that a relation is in Boyce-Codd Normal Form BCNF? It means that the relation satisfies certain criteria for functional dependencies and has eliminated all potential anomalies related to functional dependencies. To be in BCNF, a relation must meet the following conditions. 1. No partial dependencies. Every determinant, a set of attributes that uniquely determines other attributes in the relation, must be a candidate key. In other words, there should be no non-key attribute that is functionally dependent on only a part of a candidate key. 2. No overlapping candidate keys. If there are multiple candidate keys in the relation, their attribute sets should not overlap. Each candidate key should uniquely identify tuples without any redundancy. 3. Preservation of functional dependencies. All functional dependencies in the relation should be logical consequences of the candidate keys. This means that no extraneous dependencies exist that are not fully dependent on the candidate keys. BCNF is a higher level of normalization than the third normal form 3NF. It ensures that there are no non-trivial functional dependencies between non-key attributes and maintains data integrity by eliminating potential anomalies such as insertion, deletion, and update anomalies. 4. Explain the difference between attributes and identifiers. Attributes. Attributes represent the characteristics or properties of an entity or relation table in a database. They describe the data stored in the database and provide information about the entities or relations they belong to. Attributes can have different data types, such as text, numeric, date, etc. Examples of attributes include name, age, address, salary, etc. Identifiers. Identifiers, also known as keys, are special attributes that uniquely identify each record tuple in a relation table. They help establish relationships between tables and ensure data integrity. Primary keys and unique keys are common types of identifiers used in a database. Primary keys uniquely identify each record in a table, and they cannot contain duplicate or null values. Unique keys ensure that the values in the key columns are unique across the table, but they can allow null values. 5. Name and describe 3 types of binary relationships. 1. 1-to-1-1, 1 relationship. In a one-to-one relationship, each record in one entity table is associated with at most one record in another entity. This relationship indicates a strong and unique connection between the two entities. For example, consider a person entity and an address entity. Each person can have only one address, and each address belongs to only one person. 2. One-to-many one. Relationship. In a one-to-many relationship, each record in one entity can be associated with multiple records in another entity. This relationship represents a one-way or unidirectional connection. For example, consider a department entity and an employee entity. Each department can have multiple employees, but each employee belongs to only one department. 3. Many-to-many relationship. In a many-to-many relationship, multiple records in one entity can be associated with multiple records in another entity. This relationship requires an intermediate or junction table to connect the two entities. For example, consider a student entity and a course entity. Each student can enroll in multiple courses, and each course can have multiple students. To represent this relationship, a junction table called enrollment would be created with foreign keys referencing the student and course entities. 6. What is the relationship of ODBC, OLE DB, and ODBC? ODBC Open Database Connectivity, OLE DB Object Linking and Embedding Database, and ODBC ActiveX Data Objects are three technologies used in data access and database connectivity in the Microsoft Windows environment. Here's an overview of their relationship. ODBC. ODBC is an API application programming interface specification that provides a standardized way for applications to interact with different database systems. It allows applications to access data from various database management systems (DBMS) using a common set of functions. ODBC uses drivers specific to each DBMS to establish the connection and perform data access operations. OLE DB. OLE DB is a higher-level data access interface that was introduced as an improvement over ODBC. It is a set of COM component object model interface that enable access to various data sources, not just relational databases. OLE DB supports accessing data from sources such as spreadsheets, text files, email systems, and more. OLE DB providers are used to connect to specific data sources and provide the necessary functionality for data access. ODBC. ODBC is a high-level data access technology that builds on top of OLE DB and provides a simpler programming model. It is a set of COM objects and interface that allow developers to access and manipulate data from different sources. ODBC includes objects like connection, command, record set, and parameter, which provide a convenient way to work with data. ODBC can be used with both OLE DB and ODBC data sources, providing a unified approach to data access. 7. Explain the difference between structured and unstructured data. Structured data. Structured data refers to data that is organized and formatted according to a predefined schema or model. It has a well-defined structure with fixed fields, data types, and relationships between entities. Examples of structured data include relational databases, spreadsheets, and data in fixed-length fields. Structured data is typically stored in tables with rows and columns, making it easy to search, query, analyze, and process using traditional database management systems. It is highly organized, predictable, and suitable for performing complex queries and aggregations. Unstructured data. Unstructured data refers to data that does not have a predefined structure or format. It can be in the form of text documents, emails, social media posts, audio recordings, images, videos, and more. Unstructured data lacks a consistent schema, making it more challenging to organize, categorize, and analyze using traditional methods. It often contains free-form text, multimedia content, and untagged or unlabeled information. Unstructured data requires advanced techniques like natural language processing (NLP), machine learning, and data mining to extract meaningful insights and patterns. Examples of unstructured data analysis include sentiment analysis, image recognition, and text mining. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.